Hi there, my name is Lucas Moncada. I am a software engineering student at Western University and the chair of the Academic Working Group. Today, I am here to discuss with you my findings and recommendations regarding my research into the teaching quality of engineering professors in Ontario. In the most recent year of my engineering education, I had a professor that I thought was an incredible educator. I mean, he included the class in discussions on course concepts, used lecture notes that I could download directly to my tablet to take notes on, and posted his lecture slides online so that I could review them whenever convenient. Then, one of my friends shocked me when he mentioned that he didn't learn well in this professor's class. He told me that the class participation discouraged him when seeing how much other students understood the material relative to him. He didn't have a tablet, so he had to rewrite all the slide notes, which took forever. And the lectures being posted online prompted him to skip the class, given that the lectures were online anyway. When originally I thought it was abundantly clear which professors were effective, I now realized it was more ambiguous than I could have imagined. In order to better understand what makes an effective professor, my team decided that we should find out ourselves through a research survey. During this presentation, I will discuss the usage of current teaching methods, the usefulness of those current teaching methods, a usage versus usefulness comparison, the reported learning styles of engineering students, and finally, our recommendations for you, the deans. In 2020, the Academic Working Group surveyed 458 engineering students across Ontario, whereby each response corresponded to an individual's experience in a single course. The survey received responses from all 17 member schools and achieved an average 2.1% representation of each school's engineering students. So the first step to understanding students' academic needs and wants was to first explore the current teaching strategies being used. To do this, questions were asked to students regarding 12 of the most common teaching strategies used in class. Participants selected a range of usage per lecture for each of the 12 teaching strategies, such as this question displayed. As illustrated in these figures, there is a moderate variance of usages for the given teaching strategies. Notably, lectures being posted online, viewed in the top left, appears to be the most frequently used method, with a large majority of professors utilizing this in at least 3 out of 4 of their lectures, showing that most professors are utilizing technology to provide resources to their students. On the other hand, some strategies such as AV media and group activities were used relatively minimally, for which a large percentage of professors used these methods in less than 25% of their classes. One way to determine the optimal teaching methods and respective usage for professors would be to expose the difference between what teaching methods effective professors use and what the not as effective professors use. This figure does exactly this, plotting the median usage of the teaching methods. Firstly, please note that this graph is not cumulative, but instead has the not effective professors plot, the red bars, overlaid on top of the blue effective professors plot. So at first glance, it is immediately clear that effective professors implement much more teaching methods than the student labeled not effective professors. Moreover, one could speculate that effective professors put in a greater amount of effort into their teachings. On the other hand, it could be that these labeled not effective professors do not know how to best educate their students and therefore do not utilize advantageous teaching strategies such as these 12 listed. To this point, one student implored to expand on his ineffective professor's habitual instructions. My professor tells us often that he has been teaching this course for 19 years. Teaching is a strong word. Listing items and telling us to consult the textbook if we want more depth was the main approach. It is difficult to know how many other professors have similar teaching methods to this individual, and as a result, how many students are struggling due to professors' lack of awareness of what constitutes effective teaching. After discovering the usage of commonly used teaching strategies, the next logical question is, how useful are these teaching methods for students? This presented figure visualizes the participants' responses concerning their perceived benefit when taught using a given teaching strategy. Curiously, the distribution of usefulness happens to have low variance with all of the medians situated between somewhat useful and critical to my learning. This indicates that these listed methods are all relevant strategies to educate students. Moreover, this graph displays openly that student experiences with teaching strategies can vary quite drastically, especially with the methods relatively lower in usefulness. From this, one might speculate that there are niche circumstances that these methods are increasingly advantageous, despite their relatively lower usefulness. On the other hand, example problems and problems to attempt in class are predominantly critical to students' learning. It was also relevant to ask, generally, which learning methods are best for students. This figure displays these results. With an outstanding 88% of students, it is quite clear that students believe using practice questions is the superior teaching method. To this point, examinations heavily rely on answering questions to measure understanding of the material. Therefore, it is fitting that students find example problems the most valuable for their comprehension of concepts. Another interesting detail is that only 32% of students ranked being lectured an important learning strategy. Yet, according to a 2018 study, it is still the primary method of delivering course material. Another interesting insight is the order of these ranked strategies. This graph illustrates that the top 5 most useful methods all allow students to control the instruction speed, showing an intrinsic desire for students to control the speed at which they learn. Being able to control the pace of delivery when learning course material is one degree of personalized learning that educators can implement with minimal extra effort and substantial consequential benefits for students. Assessments force students to understand course material and be prepared to apply the course concepts to given questions. Given this, it was of interest to discover how beneficial assessments were to actually grasping course concepts. In the shown graph, it is displayed that although there are no drastic changes in usefulness between assessment strategies, assignments are more commonly perceived as extremely useful. Furthermore, more than 60% of students found that they were extremely useful for understanding course concepts. As a result, assignments appear to be an excellent assessment strategy to improve students' understanding of course material. In this figure, the percentage of students indicating high usefulness for assignments are depicted for each frequency of assignments to uncover the most beneficial usage rate to give out assignments. As can be seen, assignments achieved the highest usefulness percentage when used bi-weekly, increasing the percentage of students deeming assignments extremely useful to 57%. This usefulness could be attributed to enticing students to stay diligent with their coursework by frequently assessing new material. Moving on, the mean usages of teaching methods were then compared to the mean usefulnesses of the respective teaching methods by plotting usage against usefulness. To do this, the usage and usefulness values were first normalized to allow for a more apples to apples comparison. In addition, a direct proportion line defined by y equals x was added to give an idea where the optimal values would take place, given that intuitively professors should more frequently utilize the methods that are higher in usefulness. Noting this, it is clear that although there are points with residuals, all observations take place in the bottom left and top right quadrants, such as the line, showing that this proportional relationship is being actualized to some extent. To emphasize the points with larger residuals colored in orange, here is a simplified plot. The way I see it, the values above the line, the direct proportion line, are opportunities to increase the usage of teaching methods so that it better meets students' demands, while the values below the line are a bit more ambiguous to interpret, given the many reasons a teaching method might be perceived as not effective. As one can see here, demonstrations and pre-lecture material have the largest residuals denoting possible usage mishaps. More importantly, though, due to their large usefulness values, are example problems and problems to attempt in class. These methods are the highest in usefulness and are proportionally underutilized. So we dug deeper into what is actually going on with these two teaching methods. We found that example problems are very underused. Only 50% of professors use one or more example problems in at least 3 out of 4 of their lectures, all while 80% of students reported example problems were very useful or critical to their learning. It should also be further emphasized that this is only a measure of a mere one example problem being used per lecture. Similarly, when looking at problems for students to attempt in class, it was found that 40% of professors use one or more problem to attempt in class in at least 3 out of 4 of their lectures, all while 75% of students reported problems to attempt in class were very useful or critical to learning the course material. Again, this threshold is for only one problem per lecture. Furthermore, from these two facts, it is very apparent that these teaching methods are undervalued and underused. When drafting the survey, it was brought up that learning styles play a substantial part in the way students learn. So a question asking about learning styles was added where students could select a range of learning styles that best represented themselves. Presented on this slide is the percentage of students that identified with the learning styles listed on the y-axis. Notably, 81% of students identified as visual learners, and less surprisingly, 69% of students designated themselves as logical learners, given they're engineers. Independently, these two learning styles account for about 92% of surveyed students, indicating that these learning styles should be highly supported. Recommendations. It should be clear that problems in class are largely underused, and given their value to students, should be implemented at least once per class and optimally once per course concept. Empowering students by giving them control over the pace of their learning in the short term is an undervalued teaching method that should be taken into account when deciding on the upcoming unique period of education given the current pandemic. Assignments were ranked as the most beneficial assessment strategy and should be used much more often. Specifically, they should be assigned bi-weekly. Support visual and logical learners. They account for about 92% of the surveyed students. A professor might do this by adding visuals and posing questions in class. Finally, at this time, many professors are uneducated on best teaching practices with minimal changes in sight. Educating these professors on research such as this presentation will be largely important in the coming years. They are, after all, educating the people who will engineer the future.